Are you filming it?
Yeah.
Okay. So this is going to be option 2. It's problem 8. So it's number 8's equations are written in for the length. So the parallelogram bisector theorem says that the two diagonals of a parallelogram bisect each other into two congruent parts. So we know that both the blue equations are going to be equal and both the red equations are going to be equal. So the first thing you do is you see where there's one variable, and then since we have this one variable and we know that this one's equal, then we already have a value for y that we can put into one of the equations in place of y. So basically what I'm going to do is just take this other equation, and then every time it says y, just put 3x in there instead and then solve it. So we have 4x equals 3x plus 1, and then since I need to get x by itself, I'm going to subtract 3x from both sides. Then I'll have x equals 1. So now I already have the value of x. That now I can put that into this equation and solve for y. So that's not very hard. It's just going to be 3. And now that I have that, I can go back and put those into these equations for the actual length. And the nice part about this is that since these two are congruent, like the blue ones are congruent and the red ones are congruent, you only have to do one blue one and one red one because you know they're going to be the same. So I'm just going to do whichever one I think looks easier. So this one's easier because it's just y, so that's 3. And then this one is y plus 1, so that's 3 plus 1, which is 4. And then since they're congruent, this one's also 4 and this one's also 3. And then you can just add these together to get the total length. So the total length of AC would be 3 plus 3, which is 6. And then the total length of DB would be 4 plus 4, which is 8. That's it.
Wow, that was so good.